Good morning, my dear children. Welcome to e-learning chapter 2, that is sets. Already you have learned the chapter 1 through e-learning. This is the second chapter which you are going to learn through e-learning. Chapter 2, that is sets. The main key concepts which you are going to learn in this chapter are definition of a set with examples, difference between well-defined and not well-defined objects, symbols used in sets, representation of sets in roster and set builder form, types of sets, that is null set, singleton set, finite set, infinite set, equal and equivalent sets, universal set, disjoint sets, basic operations on sets, that is union, intersection, and difference, and last, that is Venn diagrams, that is these basic operations through Venn diagrams, learning through Venn diagrams. Now the first one is the definition of set with the examples. Set. The definition of set with examples. A set is a collection of things that have something in common or follow a rule. In other words, set is a collection of well-defined objects. The objects in the set are called elements. The elements of the set are represented by lowercase letters. Set notation uses the flower brackets with elements separated by commas. Name of the set Name of the set represents with the capital letters. Example you see here, A means that you will read it as set A. Set A is equal to 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5 are called elements and A is the name of the set. Now the same thing you can see in picture. Just see here a circle which consists of some of the elements in it, that is n natural numbers. Now some of the numbers are given, that is from 1 to 9 here. So these are 1, 2, 4, 3, 5, 7, 6, 9. These all are the elements of the set. So here you will represent this with set in symbolic form as capital N is equal to set 1, 2, 3, 4, 5, 6, 7, 8 and 9. Here is an element of, belongs to, and you see here the first symbol represents belongs to. The word belongs, belongs, to. Instead of writing the big word, you can simply use a symbol belongs to. Now how this symbol is to be used? Suppose the element 4. You see element 4 is present in set N. Yes. So we will write here 4 belongs to capital N. Is not an element of, that is nothing but does not belongs to. The symbol is, see, right, belongs to and just cross it, that is does not belongs to. Now you see example for that 12. Is 12 present in the set N? No, 12 is not there in the set N. So we will write that as in symbolically 12 does not belongs to N. Now you see just with a picture you can easily understand what is well defined here. You see here there is a bag here which consists of some of the things beside it. It is already opened and kept it outside the bag. You see the bag is a set which consists of well defined objects, that is what mostly we keep in the bag: pencils, erasers, scale, books, etc. So these objects, the pencils, scales, eraser, books, these all are nothing but these are the elements of the set, that is a big bag. Now we will move on to some more examples of what is not well defined objects and what are well defined objects. Just see here. a family of rich persons. There may be so many rich people in this world. So we cannot say here that it is a well defined. So for the same question, what is well defined? You see, so for the same sentence, the well defined is here a family of persons having more than 1 crore rupees. That means you can easily make out the list of the people who are having the the money which is more than 1 crore. So this is called well defined. Now another example, you see a group of tall students. This is again not well defined objects, because tall people means what is a particular measurement of the tall. So there is no proper measurement is mentioned over there. That's why it is not well defined. Now for the same, how we can represent the same thing in a well defined manner, you see the other side, a group of students with height 150 students. That means we can easily make out the students whose height is 150 centimeters. So this belongs to a set. Now, third example, that is a group of numbers. Many numbers are there. What type of numbers you're going to write? Is it natural numbers or whole numbers or any particular number that is less than so and so number or more than so and so number? Not mentioned anything. That's why it is not well defined. Now, the same thing, how we can write it in well defined manner. A group of prime numbers less than 10. That means you can easily make out the numbers, prime numbers, which are less than 10. Now, very important point here that the set theory was developed by George Cantor, the famous mathematician. You see here, this is very important for your objective. Is the set theory. Who developed set theory? The set theory was developed by George Cantor. Here is a picture of George Cantor too. Now, the next one is the representation of sets in roster and set builder form. Here, the rostered form. What is rostered form? If we write any set by listing the elements, then the set is written in roster form. Example, set of natural numbers less than 6. It means here we will write the same thing in roster form. That is, you have to name the set. So let us name the set with capital A. So capital A is equal to the set 1, 2, 3, 4, 5. Here we have written all these 1, 2, 3, 4, 5 with commas. These elements we have written with the commas, and we have listed all these because what is the given question there? We should write the natural numbers that are less than 6. So the numbers are 1, 2, 3, 4, 5. So this is called the roster form of the given question. The second example, set G is equal to all the factors of 20. Let us see what are the factors of 20. You know that factors means the numbers which are divisible with 20. That means if you divide with these numbers, 20 is exactly divisible. So you see here 1. 1 is exactly, 20 is exactly divisible by 1. So 1 is a factor, 2, 4, 5, 10 and 20. So these all are the factors of 20. So we'll write this in a roster form. The roster form is G is equal to 1, 2, 4, 5, 10 and 20. Now third example, S is equal to X such that X is a letter in the word madam. Now you see here you must write only the letters of the word madam. In that if you observe there M and A are repeated. So but you will be writing only the repeated ones also the letter it is mentioned. So that's why you will be writing only one time. So the representation of the same question in roster form is S is equal to M, A and D. This is about the roster form. Now we will move on to the set builder form. What is set builder form? If we write a set by defining its elements with a common property, then the set is in the set builder form. Let us see some more examples in set builder form. Now the first one. You see here, the question is given here, V is equal to A, E, I, O, U. You know that what are A, E, I, O, U? These are the vowels of English alphabet. So you will represent this V is equal to A, E, I, O, U is in roasted form. We are converting that now roasted form into set builder form. That is, now V is equal to X. That means these A, E, I, O, U are some elements. So instead of saying some elements, here we use the variable X, such that the two dots is mentioning such that. It is a word, two dots representing such that. So X is such that X is a vowel in the English alphabet. This is the general format of the vowels, that is A, E, I, O, U. So this is called the set builder form. Now another example, B is equal to, set B is equal to 3, 6, 9 and 12. What are these? If you observe deeply into this, these all are the multiples of 3 and less than 4. 3 ones are 3, 3 twos are 6, 3 threes are 9 and 3 fours are 12. So here the same thing, now you see how it is going to be represented in set builder form. B is equal to, again what are 3, 6, 9, 12? These will assume it as some variable x such that what type of elements these are? These all are multiples of 3. That is why x is equal to 3n. Here n is representing 1, 2, 3, 4, etc. And what is the limit of this multiples of 3 up to 4? So 3 ones are 3, 3 twos are 6, 3 threes are 9 and 3 fours are 12. So we should write the limit of n there. So n is nothing but n less than or equal to 4. This is the set builder form of the given set. B is equal to 3, 6, 9 and 12. Now third example. D is equal to minus 2, minus 1, 0, 1 and 2. How this is going to be represented in set builder form. See, D is equal to X such that what are these minus 2, minus 1, 0, 1, 2? These all are integers. So X is an integer. What is the limit of these integers up to where the integers are given are there in the set? Minus 2 to plus 2. That's why the x is lying between minus 2 to plus 2. In the same thing is represented in this way, that is minus 2 less than or equal to x less than or equal to 2. This is the set builder form of the given set. D is equal to minus 2, minus 1, 0, 1 and 2. I hope that you have understood the set builder form and the roasted form. If you do some more sums based on the set builder form and roasted form, you will understand more clearly. Now, some of the symbols which are already expressed in the previous picture belongs to and does not belongs to. Once again, you see here belongs to symbol is this here, and does not belongs to is you write belongs to and just strike it, that is representing does not belongs to. So, example you see, A is representing the elements 1, 2, 3, 4, 5. Now, I have just taken out only one element from the set 5. Is 5 present in set A? Yes. So, we write the same thing in symbolically 5 belongs to A. Now, the second example. Now, instead of writing capital A, I have used there the complete set, that is 1, 2, 3, 4, 5. Is element 3 is present in the set 1, 2, 3, 4, 5? Yes, it is present in the set. So we can say that 3 belongs to the set 1, 2, 3, 4, 5. Now, another example you see here, 7. Is 7 contains the set A, that is 1, 2, 3, 4, 5. In the set 7 is present? No. 7 is not present in the set A. So we use there that 7 does not belongs to A. So children, my dear children, I hope you might have understood some of the concepts that you have learned today in such chapter, which are very, very important for further concepts. So, my sincere request to you is read the definition of a set, try to understand the definition of set and what is well defined and what is not well defined. You can see some examples which are given or which are discussed in this module. Please you see once again, and representation of sets and roster and set builder form, and how the set is to be represented, and what are the elements. This all please once again you read, and please keep everything in your very big log, as we have already discussed in the previous chapter, that is your mind, put it in that, so that if you practice all these very well, so that we can continue the next module in a well manner. And I thank you very much, children. Today's session is already completed. So once again, you read all this, and thank you very much.